Hi, Algebra 2ers. We are solving rational equations. It's the last day in this unit. So the steps, again, are given to you over here to save us some time so we can just focus on the work over here. Now, this very first one can be solved multiple ways. But if we play the game of using the rules here, the first step is to determine the least common denominator of all the denominators in the equation. So we're used to doing this. So when we look at this first one, those two denominators, I can't factor them. They're not the same. So the LCD just means I have to include the factors. So it needs a 2 minus x for this guy. It needs an x minus 6 for that one. All right, step 2, multiply both sides of the equation by the common denominator. So because it's an equation, to keep it balanced, you multiply the same thing on the left as the right, whereas with the fraction, same thing top to bottom, all right? So like the complex fractions, I mean. So over here, we're going to go times 2 minus x times x minus 6. Over here, we're going to do 2 minus x and then times x minus 6, all right? The goal is to eliminate the denominator. So when step 2 says multiply both, the goal is to eliminate denominators. So that's where the distribute slash cancel part comes in. So the x minus 6's will go here, the 2 minus x's will go there, and now what I'm left with is x minus 6 times x plus 1. Over here, I'm left with 2 and then 2 minus x. All right, we would have to box multiply or FOIL. For the sake of space, I'm going to FOIL it. So first, outsides would give me plus 1x, inside minus 6, last, or minus 6x, excuse me, and then last is minus 6. Over here, we can distribute. We get 4 minus, 2x right there. All right. To finish this up, when it says solve the resulting equation, well, we've got a quadratic equation. So let's get it all equal to 0 so that we can factor and be done. So I'm going to add this 2x on over and subtract the 4 over. So I'm kind of multitasking here. So we get x squared. Let's see, plus 1 and minus 6 is minus 5. Plus 2 would be minus 3x, and then minus 10. All right. Here comes our factoring skills. So add, multiply, 5 and 2. If I go minus 5 plus 2, that'll do it. And then this gives me negative 2 and positive 5 for my solutions. Now, something you might have been thinking the whole time is that couldn't we have just cross multiplied back here to get the same thing? Yep. So if it turns out you just have an actual proportion, you absolutely could cross multiply and get the same results. All right, there's one last step to go though. So before I box these in, it says check to see if any solutions need to be rejected. The reason for this is you can't keep any values here that would make the original expression undefined. So off to the side, I want you to think, where would it be undefined? Well, anywhere that the denominators would be equal to 0. So set the first denominator equal to 0. That would be at x equals 2. All right, so I can't have that value. And then x minus 6, if that equaled 0, that would mess up our answers here. So as long as these aren't 2 and 6, we're good to go. And they're not. So this is our answer, and we're done. So that extra little step is really important because you may have to reject an answer. All right, let's try it again. So this next one, it's not a proportion. So cross multiplying is not an option. So go to the idea of what's the least common denominator. Right? You can factor each of these if it helps you choose. Like this is 2 times 3, 2 times 5, 3 times 5. So I need all the factors. So 2 and 3 I would need. I've already got the 2, but I need the 5. And then here, 3 and 5, they're both covered. So 2 times 3 times 5, that's going to give us 30. All right, we're multiplying through by 30 over 1. So I'm going to squeeze it in because I think I can get away with it here. So 30 over 1 here, 30 over 1 here, 30 over 1 there. All right. What that's going to do is simplify those denominators because 30 It's really 5 times 6. So the 6's will go, and I'm left with 5 times the x minus 4. All right, I'm going to do the same thing here. 30, and then I can simplify that with the 10 here. That's going to leave me with 1. That'll be a 3. So then I have 3 times the x minus 2. And then over here, 30 and 15, that'll reduce down to just 1 and 2. And so I'm left with 31 times 2. So we're just eliminating those denominators completely. All right, now when we solve the resulting equation, we got to clean some stuff up here. 5x minus 20, 3x minus 6, and that'll give us 62. Combine our like terms, and then keep going to get that x alone. So 62 and 26, that's going to give us 88. Ooh, this works out nicely. We get x equals 11. All right, you got to double check. Are there any values that would make the original undefined? Well, there's no x there. There's no x there. No, nothing to worry about because there are no x's in the denominator. So no values that we would need to be on the lookout for. So just x equals 11 and you're done. If you want to check your answers, you guys, could you plug back into this and add and see if it comes out to be 31/15? Sure. So if you're ever not sure, plug it back in, check away. All right. Last part on this page, we have x minus 2x, and don't forget, there's really a 1 right there. So LCD, if this is already in factored form, put parentheses around it to remind yourself that I need that entire factor to be represented over here. X is a factor. If you want parentheses, go ahead, but I need that factor represented. And then 1, yeah, 1's covered. So there's our LCD. All right, so that means I'm going to rewrite it this time and not be lazy. I'm going to separate this out. All right, and leaving myself some space. So now I can multiply the LCD over 1 on both sides of the equation, distributing it through on the left side. So when I multiply by x times x minus 2 here, times x minus 2 there, x, and then x minus 2 over here. All right, let's get rid of those little denominators. So the x minus 2's go there, and all we're left with is just x squared. The x's cancel here, and we're left with x plus 2 times x minus 2. Here, nothing cancels, so I'm left with this whole thing, 2x, and then times x minus 2. But the fractions are gone. So let's clean up and go from there. You might recognize this, you guys. That's difference of squares factored. So if I multiply it back out, that's going to go back to x squared minus 4. Distribute this. We get 2x squared and then minus 4x. Combine your like terms. So let's see, there's 2x squareds minus 4. All right, when we go to move this over, subtract 2x, or excuse me, x squared, those actually cancel right out. That's gone. And so then what I'm left with is just negative 4 equals negative 4x. X comes out as 1. All right, can we have x equals 1? Well, look at the original. All the denominators, if you realize, are represented in that LCD. So if I actually think about for the undefined part, setting the LCD equal to 0, that would produce x equals 0. All right, so I can't have that. This one would produce x equals 2. Can't have that. But we don't. So we are perfectly fine here. All right, let's move on to the next page. You got 2 more examples here. And just like always, they get a little bit trickier as we go. So for this one, look at all of your denominators. They need to be represented in the LCD. So x plus 5, that's already in factored form because there's nothing we can do there. This guy we can factor, and that'll factor into x plus 5 times x plus 3, which you probably could have guessed by looking at this over here. And so that means we need the x plus 3 from this one. And then over here, we're covered. All right, let's do it. If you want to try to squeeze it in here, feel free so that you can read my notes appropriately. I will split mine out. and leave myself some space here. All right, so when I come through and start multiplying by the LCD over 1, I got x plus 5 times x plus 3 over 1. X plus 5, x plus 3. So it's not hard to do this. It's just a lot of writing. So just get that down. And now simplify each of our 1, 2, 3 little fractions here. All right. So the x plus 5s are going to go. I'm left with x plus 1 times x plus 3. Here, the entire denominator cancels. So lovely. So plus 18. Other side, the x plus 3 is going to go, and we're just simply left with 9 times x plus 5. All right. Multiply everything that we can. This is going to give me x squared. Outsides is plus 3x. So that's that part. Inside plus 1x. Last gives me plus 3. If you really don't like the foiling, you can always hit pause, box multiply. Otherwise, try it. You guys are starting to get to the point where you should be able to kind of transition over to that faster method. All right, combining what we can, we got x squared plus 4x plus 21. And because it's still an x squared, we need to get everything equal to 0 so that we can factor this. So move that 9x over, subtract the 45 over so that I can get everything equal to 0. This gives us x squared minus 5x. Grab our calculator here. If we go 21 minus 45, that's negative 24. All right. That's a nice friendly factoring question. What adds to 5, multiplies to 24? Hopefully you're thinking 8 and 3. So we can go minus and plus, and then solve. So we get negative 3 here. We get positive 8 here. Before you box in that answer, don't forget, last little thing, where will this be undefined? So look at your denominators, which is your LCD essentially. Set it equal to 0. This will be undefined at negative 5 and at negative 3. Ooh, that negative 3 right there. We can't have these. So you actually have to reject this answer here because that would make the expression undefined. It won't make it equal. Only the 8 will make it equal there. All right. Last one. Think about putting that over 1. So that makes the LCD just plain old x plus 3. Try it. See if you can get through this last example. In the video, I'm going to ask you what you got for your answer. Do the best you can. If for any reason you got stuck, explain to me where you got stuck or where you think you went wrong. All right.